Hello, and thank you for joining us for today's webinar. I'm so happy to have you here with us today. Hi, everyone. Thanks for joining for today's webinar, where we'll be learning about a relatively novel and niche topic of crop pollination and hydroponic systems. I'm so glad that you chose to spend your lunch hour with us today. Okay, thank you folks for being here. I think I'm going to get started. Just some housekeeping things before we get started. My name is Gail Angelato. I'm going to be your presenter today. Dr. Lloyd Knackley and Mr. Michael Nelson, which you may also see on your screen, they're here in the webinar to field any questions you may have in the Q&A pod, address any issues you might have through chat. So yes, we're happy to be the OSU Hydroponics team and to kick off this series of October webinars. Just some basic information about how today's webinar is going to run. You may have been on Zoom meetings in the past where you're able to chat with other participants in the meeting. This session is being run as a webinar, and to keep distractions to a minimum, chat has been set so that you can chat with Michael and with Lloyd, with myself, but you can't direct chat with other participants. However, that does not mean that we don't want to hear from you. If questions come up at any time during today's session, no matter what the question is, please feel free to put it in the question and answer pod. If you have questions about webinar content in particular, it's oftentimes easier to keep track of them in the Q&A pod versus the chat. If someone asks a question and you had the exact same question, you are able to upvote that question so that it will rise towards the top. And you may have noticed that closed captioning is on. If you prefer closed captioning to be off, you can turn it off by hitting the CC button, which you should see towards the bottom of your screen. If you change your mind and you find that you want to turn closed captioning back on, you can toggle it on and off by hitting that CC button towards the bottom of your screen. As I said, my name is Gail Angelato, and I'm going to be the presenter for today's webinar session. A quick introduction of myself. I am a professor of horticulture at Oregon State University, where I'm also the principal investigator of the Garden Ecology Lab. My lab group does a lot of research on garden scale plantings and management approaches that can promote sustainability in small garden systems. I'm also happy to be part of the OSU Hydroponics team together with Lloyd and Michael. If you have any questions that you want to email me after the webinar, I'm pretty easy to find. Gail Angelato at orgonstate.edu. I don't think that there's anyone else out there with my name. And I encourage you to check out our lab website, gardenecology.oregonstate.edu, if you want to learn anything more about the type of research that we do in our program. I want to mention that this is the first of a series of Wednesday webinars that we're holding throughout the month of October. October 11th, Lloyd is going to be presenting the fundamentals of hydroponic plant nutrition. October 18th, Michael will be presenting on 2 different hydroponic techniques, buckets and nutrient film technique. And on October 25th, Michael will be presenting on 2 more hydroponic techniques, deep water culture and ebb and flow. All of these webinars are going to be held at the noon hour, just like this one. If you want to learn more about how to register for these programs, you can find the registration links on that Garden Ecology website that I shared with you. And then you'll be receiving a survey link to evaluate this particular webinar. I've also linked registrations for future webinars in that survey link as well. So I encourage you to take a few moments to open that survey link, even if it's just to register for future webinars. I do want to acknowledge our funders for this series. This webinar series is funded in part by an ODA, Oregon Department of Agriculture Specialty Crop Block Grant intended to promote greater access to educational resources supporting Oregon's hydroponics professionals, as well as doing small-scale research on the types of hydroponic approaches and crops that will prosper here in Oregon. So our roadmap for today, we're going to have a pretty concise webinar. I think that it'll take us about 35 minutes to get through the core of the material that I have for you today. I'm going to take a few moments to set the stage by reviewing crop pollination systems, and then specifically delve into the considerations that you need to keep in mind when incorporating pollination methods into hydroponic systems. Hopefully that'll leave plenty of time for questions and answers. Once again, you're also free to put questions in the Q&A pod at any time. Lloyd and Michael are there to grab and address questions that cannot wait until the end of the webinar. You'll also see a QR code on the screen. I'll show it again at the end of today's webinar. The QR code will take you directly to our survey evaluation of this webinar and provide a little bit more information so that we can continue to build strong hydroponic programming that meets your particular needs. Okay, so let's get started. Greenhouse production of specialty crops really went through a heyday explosion from 2009 to 2014, where we saw an 82%, 186% increase in the amount of greenhouse area specifically dedicated to producing peppers and cucumbers. We also saw growth in tomatoes and leafy greens as well. In the last couple of years, the growth in greenhouse production of specialty crops has slowed to some extent. However, we're still seeing very strong growth in leafy greens and tomato crops in particular. The predicted growth of greenhouse production of specialty crops is expected to grow another 7 to 8% between now and 2028. And when I'm talking about greenhouse production of specialty crops, sometimes I refer to greenhouse systems because there isn't as much research available on hydroponic systems in particular. But a lot of the considerations that we have when it comes to greenhouse production of these crops can also be applied over to hydroponic systems, specifically for today's topic, which is crop pollination. Two of the drivers behind the predicted growth of this market is that greenhouse systems and hydroponic systems are able to yield higher yields on less land, and they're also able to co-locate locally produced and fresh foods adjacent to or in urban centers where there are strong markets for the purchase and sale of these crops. So first, I'll take a few moments to review crop pollination systems. I think one of the most important things to remember for today's webinar focused on pollination is that pollination is a precursor and is necessary if you are producing crops that set fruit or for seed. Pollination in the simplest sense is just the movement of pollen from the male parts of a flower, the stamens, to the female parts of the flower, the carpel or the pistil. Oftentimes this is done by insects if you're outdoors, but if you're indoors in an enclosed system, you have to think of other methods. And it actually becomes pretty complicated to bring crops that set fruit and seed to a harvestable yield without the aid of insect pollinators. So one of the things that I'd like you to remember is if you are struggling to figure out what to grow and you're trying to solve this question of pollination in enclosed systems, that you can grow crops which don't set fruit, which don't have to go to seed before you can harvest them for sale. The graphic that I have on this particular slide was published in the New York Times in 2008 when colony collapse disorder and massive decreases in honeybee hives were really front and center in the news. And what you can see from this particular graphic is that there are several crops, such as almonds and apples and cultivated blueberries, which are absolutely dependent upon honeybees and other insects, most of which are also bees, in order to set harvestable yields. There are other crops such as oranges, strawberries, and peaches, which get improved crop quality, both increased yield size and increased quality of those crops when they're exposed to animal pollination. And once again, when we're talking about animal vector pollen, in almost all cases, we're talking about bees because bees have bodies that are totally built to be little pollinating machines. The white bars on this particular graphic, which shows other pollination methods, in this case, those other pollination methods are almost entirely wind pollination for crops that are able to self-pollinate to at least some degree. Now, if we zoom in and we start looking at those crops which are more popular in hydroponic production systems, we can see that there are several where cross-pollination and needing to figure out methods of vectored pollen movement is not as important. These include things like beans, which are able to set pods and beans via selfing alone. Things like broccoli, leafy herbs, and leafy greens, which are harvested before the plant matures to the fruiting and the seed stage. Then we start getting into those more traditional fruited crops. Things like strawberries, tomatoes, and peppers. These are all plants which are able to self-pollinate to some degree, but research has repeatedly shown that the size of individual fruits, as well as the quality of individual fruits, is greatly improved when you have cross-pollination. For things like blueberries and raspberries, even though they are grown in greenhouse and hydroponic systems, needing to have a method of cross-pollination is absolutely essential in order to ensure a harvestable and high-quality crop. And for things like cucumbers and other cucurbits, cross-pollination is typically required in order to set high-quality fruit, but there are greenhouse cucumbers which are able to set fruit with minimal pollination services. I want to talk a little bit about the perfect flower, which is a flower that is capable of self-pollinating to some degree. The typical parts of a flower are the sepals and the petals. We also have the male reproductive parts, the anther and the filament, as well as the female reproductive parts, the pistil or carpel, composed of the stigma, style, pollen tube, ovary, and ovules. Any flower which has all four of those components, petals, sepals, stamens, and carpels, is considered a perfect flower. Those that are missing one or more of those parts are considered an incomplete flower and not capable of, particularly if they're missing one of the reproductive parts or the other, not capable of self-pollination. Now, tomatoes, one of the greenhouse and hydroponic crops which is experiencing the most explosive growth and the greatest market potential, actually is a perfect flower. We have fused stamens which surround the female carpel or pistil, and when the reproductive parts of this perfect tomato flower are everted, that means that this flower is ready to be pollinated. Since this is a perfect flower, tomatoes are able to be pollinated by wind to help move the pollen from the male to the female parts of the flower. Things like mechanical vibration can also be used, but without a doubt, buzz pollination by bees that buzz, and that includes things like bumblebees, are absolutely the most effective for good tomato pollination. Just a little graph to show you the difference between tomato production in tomatoes that were self-pollinated. These self-pollinated flowers were covered by plastic so that they weren't subject to wind and they weren't subject to any insects. And you can see that just a minority of total fruit production in this particular study was represented by tomato plants which selfed. And then the researchers took tomato plants where they excluded insects by using mesh bags so that those flowers were open for wind pollination but could not be pollinated by insects. And once again, we see that a relative minority of total fruit production was represented by the wind pollinated tomatoes. And then we have the open pollinated varieties, which were open to wind pollination. They could self, but they were also flowers which were accessible to bees in particular. And you can see that the overall yield from this particular study was greatest for those flowers which were subject to insect pollination. Not only did the open field and open pollinated tomatoes have greater yield, but they also had better physiochemical properties than under self or wind pollination. So this is what I was talking about earlier when I said that even plants which are capable of selfing to produce fruit and seed tend to have higher quality fruit when they're subject to insect pollination. So we've talked a little bit about perfect flowers, of which tomatoes are one type. I want to talk a little bit now about monoecious crops, which have separate male and separate female flowers. And the typical monoecious greenhouse crop that we're used to, or that is most common, would be cucumbers and other cucurbits. Here I have a picture of squash blossoms, and you may be able to see on the top that this is a male blossom with the male reproductive parts in the center of the petals. Really, the telltale sign to tell a male from a female blossom in the cucurbits is that you can see a little nascent fruit at the base of the petals in a monoecious flower, such as a squash blossom. So we see the nascent fruit right there. We see the female reproductive parts right here. Once pollen transfers from the male reproductive part to the female reproductive part, we get pollen tube formation that goes down and fertilizes the ovaries within this nascent fruit, and then we get the expansion of that fleshy fruit around the seeds. If we don't get effective seed fertilization, then we don't get that nice expansion of the fruit around the seed. Now, monoecious crops present a real conundrum if you're growing crops indoors in a greenhouse or hydroponic system. And that's because something has to move the pollen from the male flowers to the female flowers. And normally bees outdoors render this very important ecosystem service. Early in the season, if you're a gardener, perhaps you've noticed that your cucumber or squash blossoms just don't effectively seem to be forming fruit. That might be because the bees aren't out yet. You can actually pick the male blossoms and introduce them to the female blossoms to hand pollinate your cucurbit flowers. But if you're working in a larger greenhouse system where you're producing cucumbers for commercial sale, that is normally a restrictive practice due to the time and labor that it would take. So greenhouse cucumbers, sometimes called English cucumbers, tend to either be the seedless varieties, known as parthenocarpic varieties, or they're gynoecious varieties where only female flowers are the majority of the cucumber plants that are planted for greenhouse production. Just a note, here we have a photo of gynoecious cucumbers, cucumbers where the vast majority of the plugs that are installed in the system are female flowering plants. This really makes particular considerations that you have to keep in mind when you're planning out your harvest of this particular crop. Most of the fruit is going to be pollinated in a short time period, which means that you're going to have a concentrated period of production and harvest that you're going to have to deal with. Just a note about parthenocarpic or seedless cucumbers. Even when seedless cucumbers are pollinated to produce seed, they don't produce much seed at all. Hence, they're known as seedless cucumbers. This helps to cut down on the need to actually render pollination of these greenhouse cucumbers in an enclosed system. However, the amount of labor that has to go into creating parthenocarpic seed is really high, such that the cost of parthenocarpic seed is also really high. In some areas, it's normal to see parthenocarpic cucumber seed selling for approximately $1 per seed, which would be really cost prohibitive for most commercial systems. Just a little note about some of the things that you can see if you have poor pollination on your plants. Oftentimes you may not even notice that you have poor pollination in your plants because plants will regularly abscise or cut off fruit which has not been pollinated, or cut off their flowers if those flowers have not been pollinated. But in some cases, you might get a little bit of pollination and you might start to get the development of fruiting structures for things like strawberries. You may have uneven fruit development, sometimes known as cat facing. For squash, right here I have a cross section of a zucchini that has been well pollinated. We can see seed production and we can see the expansion of flesh around those seeds. And on top of it, we have a zucchini fruit that has not been pollinated at all. We don't see seeds and we don't get the concomitant expansion of fleshy fruit around those non-existent seeds. So I want to now switch to pollination for hydroponic systems, understanding the types of crops that are grown in hydroponic systems, the ones where you need pollination, the ones where you don't need pollination. What do you do to ensure pollination for those crops that benefit from vectored pollen movement? Well, if we were working outdoors, I would say, because I'm an entomologist who studies bees and I love them, let's just rely on the bees. They're such efficient pollinators. Anatomically and behaviorally, everything about a bee is built to collect pollen. They're the only insects which specifically collect pollen to provision pollen meals to their young. And that makes them incredibly great pollinators. In the United States, there are 5 species of managed pollinators, the most abundant of which is the European honeybee. We also have mason bees in the genus Osmia. We have alfalfa leafcutter bees, Megachile rotundata. We have bumblebees, of which one species has been commercialized so that we can actually get them to nest in discrete structures and then sell them to folks that need their pollination services. And then we have alkali bees, which are really a special feature of our region of the United States. Our region of the United States has expansive acres of alkali bee fields, where those fields are specifically managed to encourage the reproduction of these bees so that they can pollinate alfalfa in the Palouse region of Washington and also northeastern Oregon as well. One thing I like to point out, if you ever happen to be driving through those regions of the Pacific Northwest, is since these areas are managed for alkali bee production, we actually do have set speed limits during key alkali bee flight season, where you are encouraged to keep your speed low so that you don't hit the bees during their active time of flight during daylight hours. Just threw that in because I think it's cool to see a bee speeding sign. You don't see that anywhere else in the country or world, as far as I know. So I want to talk a little bit about the most dominant greenhouse and hydroponic pollinator, and those are bumblebees. Bumblebees are so popular as greenhouse and hydroponic pollinators because they're capable of buzz pollination, and some of the dominant hydroponic and greenhouse crops, such as tomatoes and peppers, benefit from the buzzing that bumblebees do, which help to actively release pollen so that the flowers can be well pollinated. Berries as well, blueberries, cranberries, lingonberries also do best if they're exposed to buzz pollinators such as bumblebees. Honeybees don't have that same buzzing sound. They're not as efficient of pollinators of solanaceous crops or vaccinium crops. Some notes about buzz pollination by bumblebees. Bombus impatiens has been commercialized so that if you want to buy a bumblebee hive, you can do so at a cost of about $150 to $250 per little shoebox hive, depending upon the going rate. You would place them in a greenhouse, you would let them go and do their job. They're really great because you can purchase them and place them in these little shoebox-like hives. And they're also generalist foragers so that you can switch them among different crops depending upon what needs to be pollinated. Oh, one note that I wanted to say, because solanaceous crops as well as berries benefit from buzz pollination, a fun little party trick or a fun little school trick is to actually take a tuning fork, tune to middle C. You can strike it next to the flowers and it'll cause that pollen to release. So if you ever work with children in a garden or greenhouse situation, it's just something that's kind of fun to show them. Unfortunately, even though Bombus impatiens is the only bumblebee that has been domesticated so that you can actually go online and buy them, it is illegal to import Bombus impatiens into the state of Oregon. If you want to import them into the state of California, you need a special agricultural permit. And if you want to import them into the state of Washington, you need to ensure that you have a screen structure which will not allow the escape of Bombus impatiens into the wild. And that is because Bombus impatiens has a common name of common eastern bumblebee. It is native to the east coast of the United States. It is not native to our region of the United States. But one thing you'll notice is that this is a map of Bombus impatiens observations on iNaturalist, is that we're starting to see local increases in Bombus impatiens in northern Washington and in the Vancouver, Canada area. And that is because Bombus impatiens was regularly imported to pollinate tomatoes in British Columbia greenhouses. And of course, they escaped. And when they escaped, they started to establish in the wild. And that's a concern for several reasons. This is a graph from Osterstatter and Thompson, published in 2008 from the Public Library of Science, where they did surveys looking at where they found Bombus impatiens in and around Canadian greenhouses. And they found that the closer you get to a greenhouse, the more likely you are to find an escaped Bombus impatiens. Not only could this be potentially detrimental to our native bumblebee species, but anytime you domesticate an animal, and that includes domesticating insects such as bumblebees and honeybees, one of the consequences of domestication is that you increase the transfer of diseases in those insects. And cultivated, domesticated Bombus impatiens is no different. The proportion of gut parasite in domesticated Bombus impatiens is relatively high if we compare it to native bumblebee species. And what these researchers found is not only were they more likely to find escaped Bombus impatiens the closer they were to greenhouses, this one in Exeter and this one in another Canadian city, but they were also able to find a higher prevalence of native bees carrying these gut parasites associated with Bombus impatiens. So that creates a problem for us. It creates a problem because due to the ability of these gut parasites, these Crithidia parasites, to cross-infect across multiple bee species, we already know that these parasites can move between honeybees and bumblebees. We actually don't know the extent to which these parasites can move and hit other bee species in and around our region. We're not able to import Bombus impatiens. So what are you to do if you want to grow tomatoes and you need to have them pollinated, but the one pollinator that does the best job at pollinating these crops is actually illegal to import into the state of Oregon? Remember, once again, if you're in California, you can get a permit to import them. If you're in Washington, you can import them if you can ensure that you have a screened facility which will not let them into the wild. Well, one thing you could do is you could choose a parthenocarpic variety of tomato that doesn't require pollination or mechanical vibration in order to set fruit. Some parthenocarpic varieties of tomatoes include Carpi, Quasar, and Berry. And here's a picture of a cultivar of the berry tomato. They tend to produce smaller fruit, which tends to be too small for domestic markets at scale, but you might be able to do well selling these selling these varieties at local farmers markets or through CSAs. However, once again, remember parthenocarpic varieties which don't set seed, still need to have seed so that they can be planted, and the labor involved in producing parthenocarpic seed is quite high, which means that the cost of the seed is quite high as well. So what are you to do if you want to grow greenhouse tomatoes and you're in Oregon and Bombus impatiens is just not an option for you? Well, you can go online and there are actually horticultural vibrators that you can purchase. These are larger than the electric toothbrush varieties that are oftentimes sold to gardeners. They tend to be 110 volts of energy or run on a 6 to 12 volt motorcycle battery. Horticultural vibrators run on flashlight batteries, tend to have reduced pollination success. And one thing I do want to say, if you're going to use mechanical pollination in order to get good fruit set in tomatoes, is that the trellised design or the trellis system used in many greenhouse and hydroponic systems actually helps pollination if you're using a mechanical pollination method. And that's because the trellis system itself actually helps to transmit the vibratory waves among tomatoes in an array and gives you more efficient pollination than if you were using an untrellised system. But using a horticultural vibrator is not without drawbacks itself. It takes a lot of time and a lot of labor in order to use these instruments in order to get good fruit set. Estimates suggest that you need to look at allotting 20 to 30 minutes of labor per 1,000 plants, and that you need to allocate this during the flowering period of the tomato plants on about an every other day basis. Obviously, this is a lot of time, and time equals money when it comes to labor cost. Some folks have used handheld electric leaf blowers. Once again, these tend to work best in trellis systems rather than untrellised systems. You're still going to improve fruit set over doing nothing at all, but it's still not going to be as effective as using the horticultural vibrators. So if you are going to do mechanical pollination methods using vibration in order to buzz pollinate these tomato flowers on your own, it can be helpful to understand how to decode the blossoms themselves. I said a little bit earlier that when you have the male and female reproductive parts extended, that's when the tomatoes are best open and receptive to being pollinated. If you have malformed flowers or closed flowers, they're not quite ready to be pollinated. You can also start looking at the flowers themselves to decode whether or not they have been pollinated. If a plant has been effectively pollinated, you'll start to see some darkening at the tip of the blossom before you start getting fruit formation. Flowers which have not been pollinated look pretty pristine, quite yellow, no darkening or evidence of fruit formation. If you're going to use a mechanical vibration system. And even if you are going to use the alternative insect pollinator I'll talk about next, it's important to understand when plants are most open for pollination. Pollen tends to shed across most plants most easily during peak temperature and lowest humidity, which in greenhouse systems tends to be between 11 in the morning to 3 in the afternoon, particularly in the winter and early spring. The humidity issue is something to keep in mind. The higher humidity you have within a greenhouse system, the more clumping or clustering you're going to have of pollen grains with each other, which is not going to result in good and efficient pollination. I said before in the previous slide that flower clusters should be vibrated every other day at least. The more often you do it when the plants are receptive to being pollinated, the better pollination you're going to get. Okay, so, you know what I forgot to tell you? I forgot to tell you about the 5 pollinators which have actually been managed. I forgot to tell you one point on this one, so I want to go back real quick. Of these 5 pollinators that are managed and have been domesticated for pollination services, these are the bees that you can actually buy and use in greenhouse systems and in farm fields. Honeybees and mason bees cannot move efficiently in enclosed surfaces. They just don't work well in greenhouse systems. They fly to the windows or they fly to the walls. They're not able to effectively navigate an enclosed system, so they're kind of out of the picture. I told you that bumblebees are not available for pollination in Oregon because the only species that has been domesticated, Bombus impatiens, is illegal to import. And these alkali or nomia bees, since they nest in the soil and most greenhouse systems are not soil surface systems, they don't work well in greenhouse systems either. So we're really left with one candidate as an insect pollinator in greenhouse and hydroponic systems in Oregon, and that is the leafcutter bee, Megachile rotundata. Megachile rotundata, like many of the other managed bees, that are popular in agriculture are non-native to our region. However, they're so widely established across the United States, unlike Bombus impatiens, that there's no restriction in importing them because they're already here anyway. Megachile rotundata are solitary bees, which means that there is no reproductive division of labor and cooperation among worker bees in a hive. It's just a single lonely mama female who's collecting pollen so that she can provision her young in these little cavity systems where you can see in these nest blocks, lots of little holes drilled in these nest blocks. But the good thing about Megachile rotundata is even though it's a solitary bee, they do tolerate being close to each other so that you can get relatively high densities of this pollinator in a small area to do pollination in greenhouse systems. Another great thing about Megachile rotundata is that you can manage their emergence by changing temperature. I'm sorry, I'm just going to take one quick second to try to deal with some noise on my end. I'll be back in 2 seconds. Okay, my apologies. Okay, another good thing about Megachile rotundata is that you can actually manage their emergence by raising or lowering the temperature. So you can actually keep them in cold storage and time their emergence so that it coincides with peak blossom receptivity to pollination. Another good thing about them is that they are also generalist species so that you can put them in a variety of cropping systems and they will collect pollen from just about any flower that you offer them. They don't fly very far, unlike bumblebees and honeybees, however, so that you're going to need to stock them at a relatively high rate of about 1 block per 1,000 square feet of greenhouse space. And their adult life cycle is relatively short, so that we only have an active flight period of about 8 to 12 weeks, after which the mamas are going to pass on, and you're going to either need to order more bees or schedule your pollination services so that it coincides with the life cycle of this bee. Just one thing about leafcutter bees, if you haven't seen their nests before, I actually really love them. They're called leafcutter bees because they cut little circles out of leaves. Some of them cut little circles out of petals. And what they do is they bring a pollen nectar mass back to the nest, these little cavity tube nests, and then they lay a single egg on top of it, and they literally wrap their baby bees, those little baby bees, in little cigars of leaves or petals, so that when the egg hatches out, the larvae will consume the pollen and nectar provision. When you buy leafcutter bees, you can either buy the nest blocks with eggs ready to emerge, but more than likely you're going to find them in the pupal stage, so that you'll purchase them as cocoons. When they arrive, you want to put them in cold storage until you're ready to use them. Approximately 1 month before you're ready to use them, you want to start warming them up, 80 degrees Fahrenheit or higher, but probably no higher than 110 degrees. If you want them to do well in a greenhouse system, you can't just let them go. You need to provide them with nest materials. You need to give them access to mud. The nest materials are in the form of soft leaves, which they're going to cut to start building these beautiful nests. And the mud is because they oftentimes use a little bit of mud to cap the end of the nest. The mud can honestly just be like in a little cup of mud. It doesn't have to be anything real big. The soft leaves, oftentimes people use things like raspberry or lilac, just to give them a source of soft leaf material that they can cut and use. If you're using leafcutter bees for pollination, remember that they're going to be foraging for up to 12 weeks. If they've already done a good job of collecting pollen from the main crop that you want pollinated, you need to make sure that you're continually provisioning them with pollen and or nectar. If they happen to run out of pollen or nectar in your hydroponic or greenhouse system, they're going to stop flying and become inactive. If you have nothing other than a table of like leafy greens and you're putting these leafcutter bees out there, they're just not going to do very well. If you're able to incorporate diverse crops, something even like nasturtium, which provides a good nectar reward, then you're going to be more likely to keep these bees happy. These other plants, which may not be the focal crop that you're trying to rear, are sometimes referred to as banker plants because they provide an alternative food source for these bees from the main crop. Little thing about nesting blocks that are used with alfalfa leafcutter bees, these Megachile rotundata, they like holes that are 3/16 of an inch in diameter, and their cavity nests don't go very deep. So in general, folks don't make these nest blocks larger than 5 inches deep. These nest blocks are oftentimes drilled down the center so that they can be stacked, as many as you need together. And then I have a little squiggly line drawn here because the bees actually orient using patterns on the surface of the blocks. So sometimes you can like even write your name out on different blocks, like GAIL, and you're actually helping the bees to find their particular hole where there may be many other mama bees building nest for their young in other holes. When you're placing them in a greenhouse or hydroponic system, you want to keep them 3 feet off the ground or higher to keep ants away from them. Keep them out of the way of irrigation, sprinklers, other hoses. If possible, place them several feet from greenhouse fans. Otherwise, it makes it more difficult for the bees to fly and navigate within the greenhouse or hydroponic system. And then when you're releasing the bees, once again, like I said, typically you're going to purchase cocoons. Cocoons are oftentimes released in these PVC tubes that have a hole which is drilled out of the end of them. These PVC tubes help to protect the cocoons from mice or other things that might want to eat these developing bees. When you're placing the PVC tubes containing cocoons out, you want to place them directly adjacent to, on top of, or next to the nesting blocks so that the bees can fly out and quickly find a cavity nest home. Just a couple other things to keep in mind if you're using bees in a hydro house or greenhouse. These bees can take a wide range of temperatures, but they do work best from 80 to 110 degrees Fahrenheit. Temperatures that rise above 115 degrees Fahrenheit for extended periods of time are going to make the system too inhospitable for both the adults as well as the young. I mentioned before that if you're able to keep humidity low, that'll be great for efficient pollination. High humidity causes pollen grains to cling together, which is going to reduce pollination efficiency. And you should plan your pest control program around when you are using bees for pollination services within a greenhouse. The use of pesticides, including insecticides, but also fungicides, can be harmful for bees. Fertilizer applications may also influence their behavior. So I just want to finish up by doing a quick reminder of if you are considering the crops to plant in a greenhouse, there are several which don't require pollination whatsoever. If all of what I talked about is a little bit too much to deal with, then you may want to consider sticking to the leafy greens, the leafy herbs, things like broccoli and beans. But if you are excited to think more about pollination in a greenhouse and hydroponic system, then yes, go for it. Plant those strawberries, those solanaceous crops, those blueberries and raspberries as well. Just want to thank you again for taking time to be with us here today. To remind you of the upcoming webinars for the next 3 consecutive Wednesdays. I hope you'll join us next week for Lloyd Knackley's talk on the fundamentals of hydroponic plant nutrition, talking about nutrient solutions for hydroponic systems. And then on the 18th and 25th, Michael Nelson will be giving us a tour through the different hydroponic systems that are available, including pluses and minuses of different systems. And just want to thank our funder once again and take time for questions if you have any, and encourage you to please take our survey. Everyone who registered for this webinar is going to receive a link to the recording as well as a link to our survey. But if you want to give us feedback on how we did, you can do so right now. And with that, take a look and see. I don't see any questions right now. I'll wait a moment to see if any come in. And thank you, Michael and Lloyd, for addressing questions in the background. Does acoustic pollination have any viability outside of novelty? I don't think it has any viability. I think the sound waves that you would have to be such an extreme wavelength and high amplitude that it probably wouldn't be practical to use in a greenhouse or hydro space or really any other type of space. I mean, even with mechanical vibration, when I said that folks use leaf blowers, like to directly blow on the plants, it does an okay job, but it doesn't do all that great of a job. To mechanically pollinate plants, you really need to get right in there on top of the reproductive parts of the blossoms. And thank you, Nicholas, for asking a question. Oh, thank you everyone who showed up today. I'm really grateful that you're here. This has been recorded and it will be posted with a link sent to all of you who registered after today's presentation. Do leafcutter bees reproduce? Can they be built to sustain the population in a greenhouse system? Leafcutter bees do reproduce. Whether or not they can sustain their population in a greenhouse system Theoretically, it's possible, but you as the greenhouse manager would have to do a really good job of providing them everything that they need, making sure that they have the nectar and pollen sources, even when you're switching out the hydro house or the greenhouse, making sure that they go through a cooler period where they're able to really simulate winter and fall conditions instead of just always being in perpetual summer. So I think that it can be done. I think it would more just be a way to say like, yay, I did it, rather than being practical for a greenhouse manager or hydro house manager to manage on their own. It probably would be more cost effective just to continue to order the bees from a reputable supplier. Well, thank you, folks. Once again, my name's Gail Ingalato with the OSU Hydroponics team and also the Garden Ecology Lab at Oregon State. My email is gail.langalato@oregonstate.edu if you have any questions. And thank you for being here with us today. Hopefully we'll see you next week when Lloyd talks about hydroponic nutrient solutions. Bye now.